going to be difficult for you all to see, I know, but bear with me and have another good look at it afterwards. But welcome to this, which is one of the, I think it's called Seeing Further, events for the Royal Society celebrating their 350th anniversary. And also, of course, History of the World in 100 Objects, British Museum, BBC joint project. This is object 62, so it seemed appropriate. A scientific instrument, which is what this is, an appropriate one for a Royal Society event. Now, it's known as a Hebrew astrolabe, and I'll tell you a little bit more about that afterwards. But the reason, of course, is that it's got Hebrew markings on it, which is extremely unusual. It's got Hebrew markings, and some of the words are, in fact, in Arabic. So it's those two aspects which are particularly intriguing, but more of that in a bit. What is an astrolabe is probably a good starting point.
Yeah.
Good. I was hoping you weren't all experts at it, because I'm not, and I ought to say actually who I am. I'm a scientist in our scientific research group. I'm a specialist in metals, any period, any sort of object, any culture, so not a specialist in astrolabes. We have an astrolabe specialist here, so different questions will go to her. So she's sitting in on my lecture. And in case I forget to mention at the end, Zelda Ackerman, who is the curator of this fine object and is a great expert on our scientific instruments, she is the curator of those. She'll be talking in much more detail on some of the astrolabe aspects on Saturday at the same sort of time. So things that I can't help you do come along again. But yes, scientific research. It's not often known that the museum does have a science department. We have quite a moderate-sized one with specialists in all sorts of things, from glass, bones, wood identification, organic chemists, etc. Fairly well-equipped laboratories, and it's been there since the 1930s, so it's not a recent modern thing, in fact. But our equipment, of course, is the modern grey box run by a computer. Now this is no grey box run by a computer. This is what scientific instruments really should be like. It's a shame they're not anymore. So, back to the question, what is an astrolabe? Strange name, it originates in the Greek for astro, star taker. Its use is for, well, it has a huge number of uses. It's a multitasking object, far more complex than your average BlackBerry. It can be used for astronomical observations, observing the planets, the movements of the stars, sun and the moon. It can be used for navigation, again using some of those same things, the sun, the moon, and star positions. It was probably one of the earliest uses was in surveying, using that geometric principle of trigonometry, where you take readings of the angles at the ends of a fixed point, and you can thereby measure the position and often the height, particularly in this case, the height of an unknown of a point you can't reach. It's also used for a slightly less scientific purpose, in our view, is horoscopes. But in those days, that was all part of scientific study, interest in horoscopes and what we consider superstitious observations of the stars. As you could probably tell from the name, they probably originated in Hellenistic Greece around 150 BC. When they were used, it's known for taking measurements above the horizon of the positions of planets and stars. And in fact, there's a fairly early treatise, 7th century AD, of a bishop in the Syria region, who tells us that astrolabes then were made of metal, and that's the first reference we have to that. They were making them out of metal, and it's quite possible before that they were making simple observations using other materials, perhaps. The first metal one surviving is in fact is Islamic, AD 9278 to 928. That's the earliest one we have. This one here is dated to around about 1350, so somewhat later than that. So you can make a number of observations with it. What was the sort of person who had one of these? Well, it's obviously a high status object. It's not really cheap to make. Though this one's very small, it's fairly showy, but if you go downstairs to the Enlightenment Gallery, you'll see two enormous ones. There's the Sloane one, which is about this across, which dates to 1300 AD, a medieval European one. And then there's the one that was made for Shah Hussein in 1728, which is slightly smaller, but beautifully inlaid with silver. Fabulous finds there. And a lot of the Islamic ones are beautifully inlaid. They clearly, apart from the fact you know it's been engraved and made for a major person in royalty or a well-known personality, you can tell by the skill and the artistry of them. They weren't, they're not grey boxes. They're not just functional. They're there for show and status as well. Now, what can we say about where this comes from and when? The label tells you here 1350 Spanish, and the reason that it doesn't say anything about that on it. They're fairly rare, these Hebrew astrolabes. There's a couple of them. There's one in Paris, and there's another one in Chicago. Then none of them are signed, none of those three are signed, none are dated. But you can draw a certain number of conclusions on what's on it. And the way the months are inscribed, the wording of the months on there suggests Spain, and other factors like some of the latitude plates also fit with Spain. And the date, I believe that this is calculated using the measurements of the Julian calendar, extrapolating from that, and hence the date of 1350 or around about is when this was made. So what was happening in Spain at around about that time? Well, Spain had been conquered by the Muslim caliphates some centuries before this was made. But by this time, most of it was reconquered by Christians. But, as it seems clear from this, there were certainly Arab influences still. It's very well known there were Arab influences for a long time after that. This little instrument shows us also that the Jewish, the Hebrew aspect of it shows that the Jewish peoples in Spain were collaborating with Arabic-speaking people as well to come up with these sorts of things. And it's not the only evidence. It's well known that Jewish and Hebrew scholars were collaborating together to translate the works of Aristotle and other Greek authors. Most of the Greek authors, much of it had been lost in Europe due to fires, wars and various other things, but many had been preserved. Many of these Greek writings had been preserved in Arabic translation in the Arabic world, and at this stage they were beginning to translate them back into Latin, and the collaboration between the Hebrew and Muslim scholars was assisting with this. So clearly, although this was a time of turbulence and many different religious influences, there was collaboration going on and very useful scholastic work going on between the communities. Right, now, this is a tricky bit on how does it work. I'm going to need all my hands, I think. What what I'm going to do is I've got a few of these sheets, because it is so tiny, but even on this it's not going to be easy for you to see from the back. So if I could just hand the back there, if you could sort of stop, share out and look between you. There's 3 different ones, so it's no good everybody having different ones. You have on here, this is the front, as you can see there. As is more difficult to see, this is the back. It has a number of fixed parts and a number of moving parts, and that's the key to how it works. The main thing is known as the mater. It's sort of like a round tray. This one on the left, it's a round tray with a rim. That's it, empty of all the bits. There. A round tray with a loop on the top so you can hang it up, because for making your astronomical observations it has to be suspended freely so it can hang with gravity. So you've got that tray, then you've got this, you've got numerous plates, which are probably on the left, yes. Numerous plates, these are the latitude plates. Each one is engraved with the latitude for a particular area. These particular ones, my recollection is, this is 137 and 138 degrees. Seville is, I think, 37.38 or something, 37.38 minutes, something like that, in modern calculations. We're not quite sure which they would have used if they, I don't know exactly where in Spain they would have been using those, but one of those two would have worked. And what they do is you slot the plate into the mater tray here, and on the back, get myself out here. Now this would happen. I need one of Zilka's models. On the back, you notice there's this strange rod on the back. It's a sort of ruler, known as an aladade. And when you come to look through here, and those of you who are there, you can actually see through it. It's got a little hole pierced through it. That's for making your sightings of whatever you're aiming at, objects or planets, stars. So, for example, if you're wanting to take at night, work out time, at night using a fixed star, you know where you are, so you know which latitude plate to put in. So you aim at the star, you hold it up, focus on the star, get the angle using that aladade on the back. So you rotate that and read off the point on the side. Then on this front side, you line up the star pointer, and this is the thing I sort of vaguely glossed over, this open work thing known as a rete, which has these very strange pointy things on it, like that. Mm-hmm. And you can line those up, as you can see on there. Mm-hmm. You line them up with the star that you know you're aiming at. This does require you to know quite a lot about the heavens, rather more than I would do. Having done that, you can then read off the rim the time by using the angle that you've read off with the aladade. Now, I'm not explaining this at all well, partly because I wouldn't, if someone gave me one of those cold to do, I couldn't. But please get Zilka to tell you. Zilka to tell you on Saturday. So that's roughly how you would use all of that. And let me distribute some of those so you can have a really good look at those. What we did in the laboratory, as you can see, is we took it apart in order to do analysis. We wanted to analyse all the different components and to work out what it's made of and how it's made. It's bolted together by a pin in the middle, and I think the pin that's holding it now, if I'm right, is a later replacement. But analysis of all the other components show that they're all exactly very similar in alloy. So we're pretty confident that all the parts are made contemporaneously. And this is not a sort of fatuous comment, because quite a lot of the astrolabes that I've looked at in various different from different parts of the Islamic world in particular, they often have replacement parts, either because something was damaged and broke, or perhaps with the latitude plates because they wanted to use them in a different latitude. And you can tell this because the metal composition doesn't fit with what was originally made. And what we found it's made of, this particular one, is it's made of brass. It's made of an alloy of copper with zinc. There is, interestingly, a certain amount of tin in this, which is quite interesting compared to the Islamic ones, which are usually much purer brass, zinc copper alloy, because tin is much more available, of course, in Europe, Spain and Britain. Whereas in the Middle East, tin is pretty rare stuff. It had to be imported initially from Southeast Asia, and then later it was imported, in fact, from Europe, so it was going back again. But largely this alloy is brass. Now, why were they using brass? Oh, and actually, brass is quite an interesting alloy. I should sort of divert onto that, because zinc was quite a late metal to be isolated as such, and that's because it sublimes when heated. That means it just goes up in a puff of smoke. It goes straight to a gas when heated, instead of like most metals like copper and tin. When you smelt and heat them, they end up in a puddle. They're liquid, melted. So obviously there were difficulties early on in grasping that actually there was anything there. It had gone, so it took a while to get the hang of that one. But in fact, surprisingly, as the Romans, around about the Roman period, probably quite earlier than that, slightly earlier than that, they had grasped the concept that you could put in zinc ore, whatever they were describing it as, in with the copper, seal it up and heat it, and the copper would absorb a certain amount. And that is in fact how this one was made. It can only absorb a certain amount of the zinc from the process, just because of the equilibriums involved. Later, modern zinc, if you look at brass rails and modern stuff, it's very bright and shiny, and it has over 30% of zinc in the alloy. This has got 10. And that's because we now add zinc metal to the copper and seal it up and piece it together, because we now have, of course, zinc metal. So it is quite a different process, and clearly a different concept of zinc to what we have now. But why were they using zinc? We certainly do find that all these instruments were generally made of brass. You're looking at, say, contemporary objects here. I mean, this one, for example, roughly contemporary date, Limoges, France, possibly English. It's in fact copper and gilded. I mean, the final colour would have looked very similar. And indeed, interestingly, when this came to the laboratory, and I was reading the records that we already had in the museum on it, it said it was gilded. In fact, there's not a spot of gold that we detect anywhere. It's purely because brass is such a beautiful colour. That's how it comes out. But it's not just the colour that they chose that. It's also the properties. It has to be, as you can see from the detail, has to be very sharply engraved. It's got to be accurate and neatly engraved. Brass is perfect for that. It has to have moving parts that aren't going to warp easily. They're not too soft, so they're not going to bend too much. Again, brass is perfect for making the thin plates. Now, how did they make them? Well, this is where it's, again, difficult to describe on the scale we're looking at here. But going back to that main dish plate, the mater, the back plate was perhaps as you described, it was cast. It seems very sensible, really. Yeah. The main disc here is cast and then ground down to make it perfectly flat. So I'll tell you in a minute how we know that. But the rim, unlike many of the
Yeah.
The rim, unlike on many of the Islamic ones, is cast as a separate piece and riveted on. And if you look very closely, you might just see they have these round rivets going through the rim here. So that's made as a separate part. What we find at the the top, so you're looking here into the, just a way down the road. Sure. You're looking into, as if you're looking straight up at it. That's the little slot at the top, which they left in the rim. You can see the suspension is at the top there. They've left that so that you can slot the plates in there. Because the plates, once you put them in, you don't want them to move while you're moving the routing and things around, otherwise all the calculations will be out. So they leave that little slot there. Interestingly, the Islamic craftsmen, they do that all by casting, and quite a different way. So already we've got 2 layers, and when you come to look at the side of the very top bit, the throwing decorated suspension bits, I think you can just about see there's 3 layers, like a sandwich.
Yeah.
Yes.
Like that, and those again are riveted. You can barely see the rivets. They're these round discs which I've arrowed in red. If you pass that round, and then I just to go over the point about how you make the plates, which are thinner, much thinner than, reasonable amount thinner than the mater, which is the main tray. This is a radiograph, an X-ray of all the bits all laid out. Anything that's light is thicker, anything that's grey is thinner. And I hope you can just about see that the mater is slightly uneven. It's been ground down on the slope. They cast it and ground it, and I've noticed this in other astrolabes too. They obviously haven't got quite the ability to get it absolutely even over. But it's different from the plates, which have a more dappled effect. So they've got dense bits and light bits, dense bits, light bits. So the reason for that is because the plates are made by hammering. They hammer out the sheet, beaten out. So this is made as one disc that size, it's cast that size. These ones are made as small discs and then beaten flat, and you can definitely see that. In modern times, these things are made by rolling, and that's what these ones were made. These are from another astrolabe, which was made since the Industrial Revolution, when you could get good quality steel rollers, good enough to roll out large sheets. The quality of the steel depends on whether you can do it. Roll out large enough sheets to put out those plates. So these ones are all beaten and hammered to shape. You can just pass that round. And obviously the very last stage in manufacture, once you've made all those components and trimmed them all so that they all fit, is obviously the engraving. And quite often you can see, but I wasn't able to see on this because it's so thin. Quite often you can see the original marking outlines. You can see compass marks, etc., where the craftsman has actually been marking it out. I'll just pass that back round. Yes, so what sort of people were making? We don't have a lot of information from Europe on what sort of a person actually made this. But in the Arabic world, they often sign their astrolabes, and they often sign them with a sort of monogram, like what their profession was. And there was actually an astrolabe, a professional astrolabe, according to this, though we know very little else about them. But clearly, astrolabes were being made, and these sorts of instruments were being made by skilled craftsmen who were making other objects as well. For example, there's a very nice Islamic brass jug, which is signed by the very same man who made, if you go down to gallery 34, the Islamic gallery at the back of the museum, where you'll find other astrolabes, there's an extraordinary instrument which has all sorts of dials and cogs and moving parts. It's for telling your fortune and deciding whether it's a good day to get married, or whether you should do a business deal, or whether you should just stay at home and not do anything. Required a huge amount of skill. It's not exactly what we call science these days, but indeed a very interesting engineering exercise. So, I think probably the clock is considering concluding. So what can we actually conclude finally about this before we all come round and have a really good look and see the detail of it? Well, clearly it's made by a very skillful person. It was made for a Jewish person in an Arabic mixed society, a very educated person who had good knowledge of the solar system, was able to use this. From another aspect, there are Islamic astrolabes and there are European ones, and this is almost, one could say, a sort of missing link between the two. And from that point of view, it's particularly interesting to study which aspects are coming through from where. But I think for me, I as a scientist, I study all sorts of objects in the museum, sort of art objects, all sorts of things. But as a scientist, to use scientific techniques to study scientific instruments is another layer yet again, which I really enjoyed. And I think really it's the fact that it embodies so many different aspects. And gives us that little insight into what was a scientific way of thinking in the medieval period, with the knowledge of the solar system, knowledge of geometry, and yet still a belief in astrology. If anyone's got any questions, I'm of course happy to ask what I can. But
where actually are the Hebraic or the Arabic?
There's Hebraic. Particularly, I suppose, from where you are, around the rim.
Oh, okay.
It's in other places as well.
Okay, I couldn't see. Oh, I see where you are.
Can you see?
Yeah, now I do. Yes, now
you can see that.
I see it now.
But also on the back, I believe the months. Everything is written in Hebrew lettering.
Okay.
Perhaps questions to Sylvia?
Can I ask when and where it was found?
I don't know that. Well, where was it found?
It came to us from a private collection. We don't know where it originated.
But the origin might be in Spain, could be Toledo, maybe?
Where we don't know where it was made, we just know it could have been used in Spain. And we think it comes from that area because of the different three cultures, as we said, coming together.
The last area to be reconquered was the Granada area, wasn't it?
Yes.
But I can't remember.
But still, I mean, even after
1492.
1492. So that
But
joint working would still be existing in the Granada area in 1392.
Yeah,
I've forgotten.
before this is 1350s, around 50, 55.
Yeah.
But I mean, even after the it wasn't, the people were still there. Some. There were all sorts of things happened, yes. But I mean, it didn't mean that there were no Arabic people after the rulers left.
Does it show any particular signs of use, or would it have been kept in a cabinet somewhere just to look at?
It's in pretty good condition, but I would say no. I'm sure it was used. I'm sure it was used. I mean, there are some. The alidade is slightly smoothed here and there. The suspension loop's not actually all that obviously worn, which I...
Only that, because that's the way we see, whether we are in the centre or not, the stars still appear to be revolving around us. So the beauty of an astrolabe is whichever theory we use, it works.
It's really a stereoscopic projection onto a flat plate.
You mentioned that the plate was designed for where it was to be used.
Yeah.
Have you ever found modular plates?
Well, there's 5 in there.
They're all inside.
There are 5 in there, and they're double-sided.
So you take them out and...
So, yes, what you want them.
Where are they stored? Where are they stored?
Within there, they're quite thin. They're all in there. Yeah.
So that as you moved around, and if you were a travelling scholar, as it says here, you shifted to a
Yes, so
different
you
plate.
put the one you wanted on the top.
We have latitudes between 36 and 43.
They sit and stay with the what?
No, and they often indicate where the person who's using it was traveling or situated, because you would take one which goes is the places where you want to use it.
Could you find latitude from it? Could you do it the other way around?
Yes.
So how did they do that? Time of day and angle of the sun? And,
Time,
I presume the time of the year?
yes.
Yes, I suppose so.
It's the distance to the person.
This is a public announcement. Please do not leave personal belongings unattended.
Going to the Vegas and British Rail. When was the first astrolabe made?
If you see any suspicions,
And it's a good word, and it seems to date back to, we don't have much survive in Greek astrolabes, but it seems to date back to the literature to 150.
BC?
Making me doubt myself here. Yes, but the first slide, the middle one, dates to 957.
No, Roman.
I think it's Roman.
There is Byzantine one which is there's one which is believed to come from the Byzantine Empire, but that's later than the Islamic one, which you've mentioned.
Obviously not very common. Not very common.
They probably were, but they often haven't survived.
And particularly after the Greek world, it seemed to be the interest in astrolabe seems to have been taken over into the Islamic world. Rather than west, it seems to have gone east. And that's where particularly fine parts were developed. And then came back to Europe.
Can I ask, how does brass corrode?